All right, in this video we're going to calculate the de Broglie wavelength of a 5 kilogram projectile moving at 50 meters per second. So de Broglie said that if light can have a dual nature, he believed in the symmetry of nature and believed that everything then has a dual nature, which means in number 2 we're talking about a particle, a projectile, an object flying through the air. So he said that that object that we think is a particle also has a wave nature. And so this equation is called the de Broglie wavelength, named after himself. So this is Planck's constant on top, h, divided by mv. Some people take that mv and write it as p, as in momentum, but I'll stick with the mv. All right, so the de Broglie wavelength is going to be 6.63 times 10 to the negative 34. And then I'm going to divide by the mass of the projectile, how fast it's going, and that's how I find the de Broglie wavelength. So we have 6.63 to the negative 34, and we're going to divide by 5 times 50, and my de Broglie wavelength is 2.652 to the negative 36. 2.652 times 10 to the negative 36, and because it's a wavelength, that would be in meters. So if I had to draw that, like a wavelength is the distance from a crest to a trough, like there, or a distance from the start of a crest to the end of a trough. This distance here is going to be 6.52 times 10 to the negative 36, which means it's super scrunched together, like I can't even draw it, super scrunched together, and you barely see the wave nature of something, of particles, and it looks like they're just traveling in a straight line, but they are traveling as waves as well.